All right, if you're joining us, we were late. I had not an emergency, a medical condition that I had to deal with, so I started late. Class started with Anne, our wonderful tutor. I came back and we're doing this. First question here was a question about how you take something in one form and guess, just make a rough guess at what shape it is. So the key was to get y alone, okay? And you divided both sides by 8 here, but you had to remember that division by 8 is the same as multiplying by 1/8. So that gives you your a value, okay? And then you can pick some information out of it. So you know it's going up, but it's very wide. And this is from number 2, so it was a multiple choice question. So you could fake it. You find the vertex, you say it's really wide, and then you could look at that and match it. This question, okay, was how do you take it from one form and move it into the other? And what I said is there's 2 ways. Most math teachers would want you to use completing the square, but we already have this formula that we have to know how to use to find the vertex. So why not use it right here? Take this, use negative b over 2a, comma, plug it in to find the vertex, and just shove it into that formula. Notice the a is the a. That won't ever change. A is a. And that brings us up to speed now. Oh yeah, we had to pause while Richard took a picture. But other than that, now we're all caught up to speed, and I've turned the recording on and everybody's happy. So anybody have any questions?
Question for the equation on the left. So I had trouble graphing it. Would you just have to just make an X and Y table?
Well, this was, yes, but I think Lindsay said that this was a matching problem.
Yeah, it was number 2. It was like where you matched it with which graph.
So you could, I believe that was when I looked at them, okay, maybe I'm wrong, but when I looked at it, you could just say, okay, look, it's -3, 2, there's my vertex. And it's really wide and it goes up. So you should be able to just, of the matching, find one that looks like that. And that's good enough for this problem.
Gotcha. Thank you.
Okay, that was the faking part. Okay. A table? Nah, you don't need to. Anybody else? Others?
Is there a way to like hack this? Like if the problem is in that format, can I look at it and guess the vertex? Because there's a 3 and a -2 in the original problem.
Okay, yes. I love the way hacking has become everything. Okay. Y equals ax squared plus bx plus c. Y equals a x minus h squared plus k. Now, hang on, I'm not done. When you see something like this, our vertex, let me give an example. Suppose we had y equals 2 times x plus 3 squared, I don't know, minus 16. I think we just had that. Well, the vertex is -3, comma, -16. And that's left to the student to remember that, oh, when I pull information just directly from a parenthesis, I take the opposite. But if that's not in parentheses, I just take it as it is. And that's how I got -3, because I pull the negative. Okay, and I use the -16 because it's the same as what I see. Now, more modern books, okay, are going for an even different formula. They're saying, what if I have y minus k, parenthesis, just for no good reason, equals a times x minus h quantity squared. So in other words, what if the K is over here? Now, when you pull information out, because it's in parentheses, you take the opposite of what you see. Because it's in parentheses, you take the opposite of what you see. So if we had like y minus 7 equals 5 times x plus 2 quantity squared. You can't see the y minus 7, crap. Y minus 7 equals 5 times x plus 2 quantity squared. Okay. Because these are both in parentheses now, because we've taken the extra step of having the k in the parenthesis like this, then the rule is when you pull it out of parentheses, you take the opposite of what you see. So I see a negative, well, I see a positive 2, so I know my vertex is -2 for x. I see a -7, so I take the opposite, I use +7, and that's the vertex. So Lindsay, you said, can I hack this? Because of the form it was in, you didn't need to do all of this junk. You just needed to move the 8 over here as a 1/8. Then you could have said opposite, opposite, and you would have gotten the same answer we got here.
Yes.
But what I was, now I'm rationalizing, I guess, I didn't want to give you guys a whole bunch of things to have to remember. 2 of these are the traditional 2. This is a newer one. It's beginning to take hold, but it's not that important. If you know these 2, you can do everything. But if you like what I just showed you, go right ahead and use it. Okay, so Lindsay, does that help you a little bit?
Yeah.
Okay, all right. So that was, yeah. Okay, other questions? Anyone? Oh, no, somebody had a question a minute ago. Richard, didn't you have a question and I
No,
ignored
no.
you? No, okay. Anybody else? What about the worksheet? Anything on the worksheet itself? I know Ann, Eagle Eye Ann found several things, but how are you guys doing on just some of those problems? This, I can't stress enough, this is your test. Pretty much, this is 99% of your test. Okay. I know Hamida said, is this it? Just 10 or 11 questions? You know, keeping in mind that some of these have multiple things, like problem number 10 has 3 parts to it. But this is your test, guys, right here. Pretty much 99% of it. So is there anything on there I can help you with? Is
Mr.
it?
Professor,
Yes.
I think you said it already, but I'm kind of dumb. It's
Okay.
not gonna be multiple choice part, right?
That is correct. It's all on Canvas on Thursday, and it's just going to be a show your work. So
Okay.
at 6 o'clock, it'll be open to you. You can download it, do your work, and then upload it before midnight.
Okay, thank you.
Yep. Does everybody know for a circle, when I said label center and news, does everybody know what I mean when I say news? Does anybody need me to go over it?
North, east, west, and south.
Yeah, so what's that mean?
The
The
corners of the
top-
circle, so to speak.
Yeah,
Quadrants.
the corners. Yeah, that's I used to use the word corners and I confuse students. So I went to news and I still confuse students. Yeah. So if you had, for example, x plus 2 quantity squared plus y minus 5 quantity squared equals 49. You guys want to take a real quickie and see if you can sketch it, labeling news? There's
Yeah.
one question. Okay, we'll pause and let you guys work on that. Take about a minute and a half. So my center is -2, 5. My radius is 7. So if I graph this, oops, that's not going to be good.
I have a question.
Yeah. If your
So,
question is, does your circle have to be perfect? No, it doesn't. Go ahead.
if it looked like, x plus 2 squared plus y squared over a number, how do you turn that into that? Like the problem on the,
Okay, let me get to that
Yeah.
in a minute. Let me get to
Okay.
that in a minute. Okay. So this is the center, ordered pair, -2, 5. I went up 7, down 7, right 7, left 7. If you can't read my handwriting, I will be more than happy to redo it. This was -9, 5. Okay. If you can't read my handwriting, I'll redo this or I'll repeat it for you. That's what I mean by news: north, south, east, west, the corners of the circle.
Excuse
And
me.
you do, I'm sorry?
We should add 7 for x and y.
Each separately, yes. Because for a circle goes from the center, you go up 7, but you're going straight up, the x doesn't change, but the y does change. 5 and 7 make 12. And when you go straight down, the x doesn't change, but
That-
5 from 5 take away 7 is -2. But
okay.
but when you go sideways, now the x changes. -2 plus 7 is 5, and the y does not change. Is that okay?
Yeah. Thank you.
Okay. That's the easiest way to graph a circle that I know of.
Yeah.
And this is how, so even if you guys look, even if you guys have some bizarre circle, which trust me, I've seen students do that, and they go, there's my circle. Yeah, right. Okay. But I hope you get something a little bit better. But because you have those points labeled, that's what's going to get you the credit. Not the fact that your circle is perfect and beautiful. The fact that you've labeled those corner points, that's what gets you credit.
Okay. Thank you.
Okay?
Professor,
it's-
a quick
yes.
one, a quick question.
Okay.
Is there a relationship between the 49 and the radius of 7, or is it?
Oh, yeah. Because
It is, right?
this has to be rewritten as 7 squared. Yes.
Just for clarification. Thank you.
Yeah, the radius is 7. It's always that number. So sometimes we tell you 49. Sometimes we actually are nice and write it as 5 squared. So sometimes we give it to you and sometimes we don't. But you have to remember that the radius is somebody squared, and it's that somebody that you use over here. Okay?
Okay. Thank you.
All right. Yeah. Now, there was another question. And somebody was asking the question, was it something like this?
No, it wasn't. No.
Okay, all right,
The over 4 was underneath the x squared.
all right, well, that still doesn't matter. Okay, so x squared over 4,
Uh-huh.
and what was this? Was like y plus 2 minus 2.
Y plus 2.
Okay, quantity squared
Yeah.
equals
1.
1. Okay, now what you have to recognize here is this is an ellipse. Okay, this is an ellipse. And our standard form for an ellipse was x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. I'm right about in the glare. So this is an ellipse, but it's in a wacko form. It should be like this, but it's not. So what math can I throw at it to make this equivalent to this, to make this problem in this form? Well, what if where's my glitter? Right there. Okay. What if we call this x minus 0 squared over 2 squared? Okay, now where'd the 0 come from? Well, you can always add or subtract a 0 into something, and it doesn't change its value. It's there, but it doesn't do anything. But that helps us find the center. Okay, now what about this? Well, it's missing somebody down here. But what can I always divide by that doesn't change anything?
1 squared.
1 squared over 1 squared, because 1 squared is still 1. And I know that anything divided by 1 is itself. So we can sneak in those quantities because they make our problem match the format that we want. We can always add or subtract a 0 to anything, and that won't change it. We can always divide by 1 or multiply by 1, and that won't change it. So taking this format and a little bit of basic algebra, we can write it that way. Is that the first question? Is that okay?
Yeah.
Does that make sense? That's okay with you? Okay. All right. Second question, does everyone know how to graph this? Could you graph this ellipse? And again, label news. Now this is different, a little bit different from a circle. For an ellipse, you're going to be asked to label the center and news, north, south, east, west, all that kind of crud. But this time it's got an X radius and a Y radius. You guys want to take like 1 minute and try that? Or you just want me to do it?
I'm gonna try it.
Okay, try it. We'll pause. All right, so does everybody understand back here on this problem how I knew it was an ellipse? Just glancing at it? Okay.
Yes.
It's divided, X is being squared, Y is being squared. They're both positive. That's a plus Y, that's a plus X, but this is being divided by somebody. Okay, that's what makes it an ellipse. When the X or the Y or both of them are being divided by somebody, that changes it from a circle to an ellipse. You notice in the circle, neither the X nor the Y are being divided by anybody. Okay, all right, so let's do the graph of this thing. Okay, we have a center at, let's go over here. Our center is at 0, -2. right here. Our X radius is 2 because it was 4, but we had to write it as 2 squared. Okay, and our Y radius is 1 because of that. Okay. So 0, comma, -2, boom, boom, is right about there. So in the X direction, we're going to go 2. Now this is different than a circle. In a circle, the one we had here, we went up 7, down 7, right 7, left 7, because the radius is always the same. But we have to think a little bit more in an ellipse. In an ellipse, X is 2. So we're going to go left and right 2. So when we do that, we come over here 1, 2. So this point would be 2, -2. Back 2. This would be -2. Whoops. -2. Our Y radius is 1. So from the center, we're going to go up 1 and down 1. From this, everything is measured from the center. So this is 0, -3. And this point here is 0, comma, -1. And that would be an ellipse. That okay? And that's the news on an ellipse. All right. Well, I got you guys. Did anybody see the email from our chancellor, community college chancellor today? They're going to expect all students and staff, anybody on campus, to be vaccinated by the fall. So if you haven't done it, you should go out and do it. I don't know how they're going to make sure you've been vaccinated, but that's gonna, she put that in her letter to all of us, and it was in bold face, jumped out, starting in fall, this coming fall, not the summer, but the fall. They're expecting everybody to be vaccinated against COVID. So you might want to make those plans.
Wait,
Again, go ahead.
I want
I'm
to
sorry.
don't erase.
Pardon me?
Don't erase the board.
Oh,
please.
okay. All right. I won't. So, anybody else have any questions on that, on just the review, anything? Anne did a good job on the first few, and I guess she started on chapter 10 and I screwed up on the, not chapter 10, problem 10. Anything else? You want me to do problems?
I had another dumb question.
I think you maybe asked one dumb question all semester and the rest of them have been really good.
I don't know. You haven't heard this one.
Okay, go ahead.
I could not for the life of me figure out question number 1 on the right triangle geometry mom homework.
Do you want me to look it up, or do you remember? What
Okay,
it
it
was?
says a triangle has side lengths 20 and 26. Which of the following lengths of which of the following could be lengths of the third side? And it gives you 5 different boxes to check.
Okay.
All the formulas I plugged these into to get the third side, none of them came out to any of those numbers.
Why are my headphones going wacko again? Okay. So the thing I see, this could have been 20, 26, X. the 26 could have been the hypotenuse.
Yeah.
Okay, could have been. And the hypotenuse is the longest. So you have x squared plus 20 squared equals 26 squared, right? Okay. Yes or yeah, makes sense.
Yeah, I got that.
Okay, so what do I have? So I don't know what 26 says. X squared is what's 26 squared? 576, is that right? Take away 400. Is that what 26 squared is?
I got 676.
676. Okay. Take away 400. Okay. So I have x squared equals 276. So if we square root both sides, second square root. Okay. I get x is 2 radical 69. Or did it say anything about rounding? 16.613.
No, see, I got that, but then all the options I have on the list are whole numbers
Okay, well, hang on a minute.
rounding.
Hang on.
Be one of them 30, 60, 90 triangles? Or is it a right triangle for sure?
It doesn't say in the problem, it just says a triangle.
A triangle?
Yeah, a triangle, like a
Oh,
single.
not even a right triangle.
No, it
isn't
just says a triangle.
Oh, oh, that's a totally, I didn't listen to you. That's not a dumb question. Okay. That's actually a real subtle question. Okay. The sum of any two sides of a triangle have to be bigger than the third side. So, for example, if I told you I've got a triangle has 5, 8, and 20. Those are the sides. Could it be a triangle? No, because if this is 20 and this is 5 and this is 8, they don't close the gap. Okay, they would just kind of go fall and you wouldn't have a triangle. So it comes from geometry, and that's not something I taught. And I'm surprised it was there. I need to go look at that. The sum of any two sides must be bigger than the third side. So
Oh.
otherwise it wouldn't make a triangle. I mean, any idiot can put numbers up here like I did, 5, 8, 20, and talk about it being a triangle, but it can't be a triangle. Okay, it can't physically make a triangle. Okay, so what if we had one side was 26 and this side is 20? Okay, well, this other side here, the sum of any two sides has to be bigger than the other side. So question, could this be 6?
No.
No, because they would be equal. And what would happen if you did that, just to show you, you'd get 6, you'd get 20, they kind of touch together and then make 26, but they wouldn't hold themselves up in a little tint, making a triangle. Okay, so this could it be 7? Yeah, it could be, because the sum of these two sides is bigger than that. So they gave you those two, those were two sides. So they'd have to be actually any number bigger than 6 would be the other side. Any number smaller than or equal to 6 would be no good. Does that help?
Yeah. But I mean, my problem still says I'm wrong.
Would you?
Hold on. Oh. Okay, so it says that the answer is 31 and 43.
What were your choices?
31. Oh, okay, I see it. It was 31, 53, 46, 43, and 6. So it couldn't have been 46 or 53, right?
46 or 6, you said?
6 was one of them too.
Right. Okay. So it couldn't have been 6 because of that.
Yeah. So there was also 43.
Okay. So if this was 43, does that work? Is the sum of any two bigger than the third? That seems to work, doesn't it? What about 53?
No, it's odd.
What's odd? What?
I'm
What
just
am I?
playing.
Huh? Those are your choices: 31, 53, 43, and 6.
And 46.
Oh, and 46. Okay, well, 46 I can delete because 26 and 46, 26 and 20 equals 46, and they have to be bigger. I don't know why 43 is wrong.
No, the 43 and 31 are right.
Why is 53 correct? Why is it? Oh, that's why. Stupid. Okay. Because the sum of these two sides makes 46, but it's got to be bigger than 53.
Oh, okay.
Okay. And again, you keep coming up with really good questions that aren't going to be tested. But does that help you? That wasn't a dumb
It
question.
does help me.
That was not a dumb question at all. I mean, that's called the triangle inequality theorem. The sum of any two sides has to be bigger than the third side. Are you taking trig next semester or this semester?
I'm taking it in the fall.
In the fall? Okay,
Yeah.
remember that. That
Okay,
keeps coming. That keeps coming up.
Thank you.
That'll be a good one. Yeah. Okay, Richard, you started to say something. Were you just kind of jerking me around, or
No, I'm fine. I was
you
playing with those
okay?
numbers.
Okay. All right. Anybody else? None? How are you guys doing on the 30, 60, 90 triangles?
Can we do one of those? Oh, no.
How about that? If that's 30 degrees, that's a right triangle. That means this is 60. Okay. And I already told you this side is 6. Can you find the other two sides? I'll pause while you guys think about it. Okay, going back to our notes for a 30, 60, 90 triangle. Okay, in a 30, 60, 90 triangle, the sides opposite the 30 degree was the key. We call that A. Okay, the hypotenuse, which is opposite the right angle, is always 2A, 2 times A. And opposite the 60 degree angle is always A times the square root of 3. So your first job when solving this problem or figuring out this problem is, what side were you given? Were you given the A side, the A radical 3 side, or the 2A side? Which one were you given? And because you were given the side opposite from the 60, you can say, this 6 is the A radical 3 side. That 6 is A radical 3. So you want to get A. So divide both sides by radical 3. And I have 6 over radical 3 equals A. But, okay, we don't like radicals in the denominator. So we learned how to rationalize top and bottom by radical 3, radical 3. That becomes 6 radical 3 over normal 3. Where's my glare? I'm still safe. Because radical 3 times radical 3 is radical 9, but square root of 9 is 3. That reduces down to 2 radical 3 equals A. So after all that work, this side was 2 radical 3. Okay. The y is the hypotenuse side. It's to 2a. Okay, so it's 2 times this. So y is 2 times 2 radical 3. So it's 4 radical 3. And you're done. Yes or no? You guys okay? What about that worksheet? We hadn't gone over it, the one with all the 30, 60, 90 triangles on it and stuff like that. Practice on it. I put it up there with the answers somewhere. Anybody find any of those that you wanted me to go over? Or are we finding questions that you're going to look over for tomorrow night?
On the worksheet, are you able to do number 3? I don't know if it's been done already, but it's
The
the
one that's
equation of
45 degrees and the one side is 3 radical 2 over 2.
I'm
Is that
looking
correct?
at the not are you looking at the multiple choice? I'm looking at the practice problems. Number 3.
Oh, find the equation of the circle in standard form, that one?
Yes. Mm-hmm.
Okay, so leaving special triangles behind. Okay, before I do Lindsay's question off the practice one, any questions about this 30, 60, 90, finding the missing sides? Okay, then this is off the practice. Number 3, I want the equation of a circle and the end points of the diameter are 4, -2, and -2, 10. All right, let me get some more ink. Sorry. Okay, so, well, first off, what's this mean? The endpoints of the diameter. If we think of a circle and this is 4, -2, 1, 2, 3, 4, right here, 4, -2, and -2, 10, and that's the diameter of a circle. Question, what is a diameter? What's special about the word diameter of a circle?
All the way across?
Okay, going through who? Okay, let me draw this. Here's a circle. Okay. Is that a diameter?
No,
Why?
because it's not going through the middle.
Bingo, that's the key. The diameter goes from one edge to the other edge, and it goes through the center or the midpoint. Okay, so because they said this is the diameter, okay, I have there, it gives me several keys. One, the most important, or at least for now, is the center is also the midpoint. So with that in mind, by the way, this is called a chord, C-H-O-R-D. C-A, you don't need to know that. I'm just throwing vocabulary at you. A chord is any point, excuse me, or any segment that joins one edge of the circle to another edge that doesn't go through the center. So those are called chords. Okay. What do you call the thing that goes from center to edge only? From center to edge only. What's that called?
Radius.
Radius.
Radius. Yeah, radius. Okay. So a little bit of vocabulary there. All right. So anyway, wait a minute. Let's go back to this. Here's a circle now. I know that that's a circle. Yes, it is. It's a pretty spazzo circle, but that's a circle. I want the center. How am I going to calculate the center? Well, the center is the midpoint, which you guys all did with Ann, which is average the x's 4 plus -2 over 2, comma, average the y's, -2 plus 10 over 2. Okay, so that's 2 over 2, so that's 1. Is that right? Oh, well, what an idiot. Okay, never mind. Somebody can tell me why I'm wrong here, but that's okay. 1, and this is 5. 8. -2 plus 10 is 8. 8 divided by 2 is 4. Can anybody tell me what's
Wait, I'm
really
confused. You did -2 plus 10? Should have been.
is 8?
The second.
-2 plus 10 is 8
Because it's
divided
X's
by
and then
2.
Y's, right? Oh, I see. I see. Okay, never mind. Never
You're
mind, I got it.
averaging the x's. Okay. Can
I
anybody
was
tell
wondering
me?
why you did the 4 and -2 over there, but I got the gist of it, what you were
Oh,
doing.
it's yeah, they happen to be
Oh no, I
it's
meant on the
those
graph.
two. Those are my x's and these are my y's. Yeah, that's what I was using. Yeah, but can anybody tell me what thing I really man, that's what you get for spending the day at Kaiser. I really blew on this drawing. I blew it. Just
First point is graphed wrong.
yeah. 4 -2 should be over here. +4 down 2. Okay. Yeah. The math is going to work out right. Just my drawing is wacko. Just really wacko. Let's see if we can do it again. 4 -2. 1, 2, 3, 4, -2. And -2, 10. Somewhere up there. Better. And I just figured out the midpoint is 1, 4, and that seems much more reasonable. I still have a circle that looks something like that. Phew. Okay, so what's that tell me? Well, it tells me my equation of a circle. Okay, this is where you have to have it. Remember, a circle looks like x minus h squared plus y minus k quantity squared equals r squared. So what I've just figured out is the 1 and the 4. So I'm down to here, x minus 1 quantity squared plus y minus 4 quantity squared equals something. Okay. Now, to finish off this, all I have to do is figure out what the radius is. There's 2 ways of doing this. And we talked about this last week a little bit. There's 2 ways of finding the radius. One way is just use the distance formula that Ann was talking about. That is the radius. So use the distance formula on that. Okay, so whatever that is according to the distance formula, you put it right here, put a little squared on it, and walk away. You're done. That's the equation of the circle. There's an alternate way for this particular problem. Okay, and that is the circle has to go through these points. So you could pick a point. I'm going to pick 4, -2 and plug it into my formula. Okay, what I'm talking about is I'm going to plug 4, I'll get out of the way in a minute, -2 into this problem, x minus 1 squared plus y minus 4 squared equals r squared. So stepping aside, we're down to here. All of the points that are on the circle here have to make it true. That's what being on the circle means. If I plug them in, okay, they'll make that problem true. So I'm going to plug it in to help me figure out what r was. So if I plug this in for x, this is 4 minus 1 squared plus -2 minus 4 quantity squared equals r squared. 4 minus 1 is 3, 3 squared is 9, plus 2 minus 4 is 6, 6 squared is 36, equals r squared. Okay, add these together, what do we get? 45 equals r squared. Okay, now hang on a minute. Okay, first off, do you understand the math I just did? Do you understand first how I got the center? It's the midpoint of the diameter. And that meant my equation got to here. Okay. Then the next thing I said was, look, all of these ordered pairs that are here on this circle, I have to be able to plug them in, and they have to make the problem true. Okay, so I plugged them in for x and y and help me solve for r squared. Okay, now mom will have a fit because I will accept this as a final answer. Oops. I will accept that you just put the 45 over here in place of r squared. Because the equation says, the problem says find the equation of a circle. So that's good enough. Okay, but what if the equation had said, and find the radius? What if that had been added to the problem? This is the correct answer to this problem. Find the equation of a circle. But what if it had also said, and find the radius? What else would you have to do? Isn't the radius, wouldn't you have to square root both sides to get the radius? So you're going to get the square root of 45 equals r, because that's the radius. Not r squared, but r. R squared is part of the formula, but r by itself is the radius. So clean this up, 3 radical 5 equals r. So there's your radius. So if that had been asked and give me the radius, you'd say 3 radical 5 is the radius. If it just said, give me the stupid formula, that's the stupid formula. Okay. Who asked for that one? Was that Lindsay? or somebody else?
Not Lindsay.
Okay. Anybody else? Any questions, or Lindsay some more? Oh, quick, Mitch and Cameron aren't here. We can ask a lot of questions. We can make fun of them too, but we shouldn't do that.
So I use the distance formula, but I'm getting a different answer.
Okay, that's pretty good. I like the fact that you use the distance formula. Which 2 points did you use?
Um,
Because you could have gone from this endpoint to this endpoint and divide by 2. Or
yeah,
you could, I'm sorry.
I use the original points.
The original points? Okay.
Yes.
So I want to make sure everybody understands, okay, what we're doing here.
Is she looking for the radius? I'm not sure what.
Yeah, yes. She's looking for the radius, but instead of plugging in like I did here, she's going to find the diameter and cut it in half to get the radius. Okay? Which is it's a very straightforward way. If the problem says I got to find the radius, then I know that half the diameter is the radius. So she's using the distance formula is 4 minus a minus 2 squared. So x minus x and negative 2 minus 10 squared, y minus y. Okay, x minus x, or just think about it. What's the distance from negative 2 to 4? 6. So that's what this is. This would be 6 squared plus, what's the distance from negative 2 to 10? 12. From negative 2 up to 10 is 12. So plus 12 squared. Okay, so this is 36 plus 144. That's the square root of 180. I think that's right. Maybe I better take my calculator and double check.
You're right.
Am I right? Okay. So now what's the square root of 180 simplify as?
13.4.
No, as a radical.
Oh, okay.
6 radical
Six
5.
rad-
6 is yes, no, 6 radical 5.
Correct.
Okay. So that's our diameter. Okay, that's all this was diameter equals, or distance equals, distance equals. So the whole distance across here is 6 radical 5. But the radius is half of the diameter. So we're going to go half times 6 radical 5, which is 3 radical 5, which I think is what we got over here. Or I erased it, but that's what we had. So that's the radius. So you could have said, equals 3 radical 5 radius squared. Now, if you square that, you'll get 45. Those are the same answers. Okay. Now, I don't know if mom said to round as a decimal or to give exact answers. A lot of the problems on my test are giving exact answers like that. Does that answer your question or not?
Yes.
Okay. Anybody else? So this is the traditional way. This is the way I like. The other way that I showed you about plugging in, that's acceptable, and you get 100% credit for that. But personally, this is the way I always think about it. I always do it. But I can't stop you from doing proper math. So
So when you tell us to look for the distance, we're actually looking for the diameter of it?
in this problem, yes. Yes. Okay, anybody else?
Professor, in that circle, and I didn't catch on, and I think you did on quick, the order pair of 1, 4 in the middle.
Yeah.
Was that just like your observation right there?
No,
Or
that was
how'd
the
you-
midpoint.
Okay, you used that one. Okay,
I
got it.
use that. The problem gave me the endpoints,
Uh-huh.
but I knew that the center was the midpoint. So I use the midpoint formula.
Okay, got it.
Okay. Anybody else? Okay. Any questions? Anything anybody wants to ask? I think we've identified a whole bunch of things. I've got to fix your answer key on this for tomorrow. I'll put up a new one. You guys got to look at these problems on the practice and figure out which ones you know how to do and don't know how to do. And ask me a whole bunch of questions tomorrow, me or Ann, it doesn't matter which. But I'm still here. You guys can check out anytime you want, but I'll keep answering questions if anybody has some. None?
I do. So
Okay.
I'm having a little trouble with the parabola ones when they're not in standard form. I'm not
Oh.
sure how to graph them.
Okay, was this like on number 2 on Mom?
Yes.
Okay, yeah, where were you when Lindsay was asking the same question? Damn it. Okay, go ahead, read it to me.
It's a whole bunch of them, but I mean, we could just do one of them to kind of get an idea of what I'm doing incorrect.
Go ahead.
So I'll just do the first one, which is A. It's parentheses x plus 3 squared
Yeah,
equals 8 parentheses 2. Y minus 2.
okay. Now, Lindsay earlier asked questions about this, and we found that there might be an easier way to do it, but I'm going to walk you through a straightforward way. Okay, first thing I'm going to do is distribute the 8 into here. So that's going to be x plus 3 quantity squared equals 8y minus 16. Add the 16. Oops, add the 16. Now, this is the first trick. We're going to divide everybody by 8 because we want to get y alone. That's our format for a parabola. We want to get y alone. But instead of saying divided by 8, we're going to multiply it by 1/8. Dividing by 8 and multiplying by 1/8 are the same thing. 16 divided by 8 or 1/8 times 16, they're all the same. It just depends on what you want to write. Okay, example, x divided by 2 is the same thing as 1/2 x. So over here, when I had this quantity divided by 8, it's the same thing as 1/8 times this quantity. Plus 2, 16 over 8 is 2, equals y, and I'm just going to move the y over here. Okay, so, and again, you could have done this probably in one step. You could have done it with your eyes closed. But that's taking this problem and manipulating it to look like this. What I'm looking at is this is y equals a times x minus h squared plus k. So Are you okay with my arithmetic so far?
Yes.
Okay, so really cool here. First off, my A is positive 1/8. Okay, positive 1/8. This means it's going up because it's positive, and it's very wide because it's a fraction. When your A value was a proper fraction, the smaller and smaller and smaller it gets, the wider the parabola is. So all of the 1/8 tells me up and very wide. My vertex is -3, 2. So with minimal work, okay, I know that this goes from -3 to something like that. It's going up and is really wide. So you should be able to match it with something. With just that bit of work, you should be able to do a real quick match. Is that okay or not? There should be
Yes,
only one
that's
of them.
fine.
There should be only one of them that looks even close to that.
Yeah.
Okay,
I was just getting confused. I was dividing everything by 8. But I think the 1/8 seems a little easier.
oh yeah. Well, you have to do that in order to get the A value.
Yeah.
Yeah, so our math says, okay, divide everybody by 8. Yeah, but over here you have to say, oh yeah, I got to make that little change, and that makes the problem come clearer. Was there
Yeah, that
another
makes much more sense.
was there another problem on that you want me to kind of go over real quick?
Um, if nobody else has any questions, I wouldn't mind going over another one.
Shoot, go ahead.
Um, it would be E, which would be x plus 1 squared equals 12 parentheses y plus 1.
Okay, it's going to be exactly the same as this. Okay, so we're going to have x plus 1 quantity squared equals 12y plus 12. Move the 12 over. So x plus 1 minus 12 equals 12y. Divide everybody by 12. Okay. Use the 1/12 trick. Okay. So x plus 1 squared minus 1, because that reduces, equals y. So once again, I know my A is positive 1/12, which means it's definitely going up. Okay. And it's wide again. As a matter of fact, 1/12 is smaller than 1/8. So this should be wider than this one was. Okay. The smaller the fraction, the wider it gets. The smaller the fraction, the wider and wider and wider it gets. So this is going to be really wide. But our vertex is -1. Whoops, -1. Take the opposite of that. Take exactly what we see of that. Anything in parentheses, we take the opposite of. So you see a positive 1, but you write -1 for x. If we're taking it outside the parentheses, we just take it as it looks. So from this graph, you could say, okay, my vertex is -1, -1. Okay. Okay. And it's going up, and it is way wide, like that. That's it. You could also put these, if you're really lost, you could put these into Desmos. Desmos will graph it, I think, in this form. Desmos will allow you to graph it in its original form, and you can kind of spend some time thinking about it. How did Desmos get this answer? One of the cool things about Desmos is you can trace right along here and find the vertex and find some points along there. But is that okay?
Yes, thank you.
You're very welcome.
I have a question, Larry.
Okay.
Yeah, is it a coincidence, or if we look at the problem itself without doing anything?
Yes, Lindsay asked that earlier, and
Yeah.
that,
Okay.
yeah, and that, what I said earlier was I only wanted to teach the two basic forms. Okay, either y equals ax squared plus bx plus c, or y equals a x minus h squared plus k. Those were the only two forms that I wanted to teach, because I recognize that if I start showing you all kinds of options, I'll confuse people. But what I said was there is another option. Okay, if you take this as y minus k quantity squared equals a times x minus h. Am I in the glare? Yes, I'm in the glare, idiot. Okay. If you manipulate this around to y minus k quantity squared equals a times x minus h quantity squared, then instead of playing the game we played up here, where I said, if it's in the parentheses, you take the opposite of what you see. If it's out of the parentheses, you take exactly what you see. See, you got to play, sometimes I use the positive, sometimes I use the negative. If you move it into this form, then you always use the opposite of what you see, always. So back up here, in its original form, I see a positive one, I use a negative one for x. I see a positive one, I use a negative one for y. Okay, it always works. With the one exception, you still need to move the 12 over, because you still have to get the a value.
Yep.
But other than that, that's the third way. Lindsay had asked that a little bit earlier. I think it was Lindsay, whatever. And I just resisted showing you that, showing the students that, not because it was wrong, but because I was trying to actually minimize how much they had to learn. So I made a conscious effort not to teach that.
Okay.
But we've done it. But so you're right. Okay, whatever. Anybody else? None? Okay. I'm going to go check on my wife. She actually, well, the reason I was at Kaiser today is she had a gallbladder removed. Okay, and she's in a great deal of pain. And oxycodone takes care of some of it, but not all of it. So I'm going to go take care of my wife. And I'll be back here on time tomorrow. You guys all put together a whole bunch of questions. Okay, and thank you, Anne, for starting the class for me.
No problem.
All right.
Take care.
Bye-bye, everybody. Bye-bye.
Thank you.
Uh-huh.